So we're going to determine the behavior of the graph of a polynomial function using the leading term test. Don't know what that is right now, but you will soon. Factor polynomial functions and find their zeros and their multiplicities. So all of these are examples of polynomial functions. When you just have a constant, okay, a constant means that your equation is just going to look like y equals some number. Okay, if it is linear, the highest power of x is going to be an x to the first. If it's quadratic, the highest power of x is going to be an x squared. If it's cubic, the highest power of x is going to be x cubed. And if it's quartic, the highest power of x is going to be an x to the fourth. So when you see those things in your equations, you should be able to kind of pick out, okay, that one's linear, it's an x to the first is highest power. You already know a lot about quadratic equations because we've worked a lot of those. Those make a parabola when we graph them, and the highest power of x is an x squared. We've worked with cubic functions a little bit. But we haven't talked about quartic functions, I would say hardly any at all. But we're going to look at these a little bit more today. So going to kind of work backwards here. Do you see how this function has an x to the fourth, an x to the third, an x squared? It kind of goes down from there. There must not be an x to the first power. They didn't list one. But in order for us to kind of fill this out, we want to list them in order from the least to the greatest, or the biggest, I said that the backwards, the greatest to the least exponents. So this one started with an x to the fourth, an x to the third, x squared. So you always want to list your biggest exponent that goes with x first. That thing is going to be your leading term. Okay, so this one has a leading term of negative x to the fourth. The number in the front of this, which just happens to be, on this one, it's just a negative, is your leading coefficient. So if it's just a negative, we would have negative 1 x to the fourth. The degree is, this is a fourth degree polynomial because the highest power exponent that we have is a 4. We back up, we want to make sure that x to the third is the highest power exponent that we have in this equation. And it is because we've got a 3, a 2, and this would be an x to the first power. So our leading term is x to the third, has to be the highest power exponent. There is no number in front of this. And if there's no number, we know that our leading coefficient or the number would just be 1. And this is a third degree polynomial because we don't have any exponents on the x that are higher than 3. Once again, I'm making sure that these are in order. So I've got an x squared. This would be x to the first. So this is the highest power of exponent I have on x. So 4x squared would be my leading term. 4 would be the leading coefficient because it's the number in the front. And then this is a second degree polynomial because the highest power of exponent I have on an x is 2. This is an x to the first. It looks like that is the only term that has an x. So this is, the leading term would be 2/3 x. My leading coefficient would be the number in the front. And this degree would be a first degree because it's x to the first. Okay, there are no x's on this thing. It's just f of x equals 3. If I were to graph this, it would be a horizontal line that's just flat. So we don't really have any of these things. A coefficient is a number that comes in front of a variable. So we just have this as a constant. So we don't have that stuff. Okay. I do think that this is going to be, for the most of this stuff is going to be a review of what we just got through doing on test 2. But they're wanting us to look at this function, x squared minus 2x minus 3. If we go over here and look at this, we know that this is a parabola. We know it's quadratic. It's a second degree polynomial because the highest power of x is a 2. We can look at the graph and tell that we have some x-intercepts. Our x-intercepts are 3, 0 and -1, 0. So we can come over here and write those down. Okay, I have a graph, so I can tell that from the graph. They've also got it factored for us. So if they have it factored, I could also find my x-intercepts by setting these two things equal to 0 and solving them. So x is equal to -1 and x is equal to 3. Those are my x-intercepts. I knew that from looking at the graph, but I could also solve it and find it. And when we list the zeros, we just list -1 and 3. We don't list the whole point. So when you're finding x-intercepts, you're looking for the place where y is equal to 0. But when we find y-intercepts, we're looking for when x is equal to 0. So right now, my equation that I have up here at the top is x squared minus 2x minus 3. So if I go and I plug in, instead of my x's, I go in and I plug in 0 for x. So I just insert a 0 in here for x. When you start multiplying things by 0, they kind of just disappear, right? So this whole term, 0 squared is just 0. -2 times 0 is just 0. So we're just left with this constant term on the end. So my y-intercept is going to be when x is 0 and y is -3. That is also on your graph over here. We could have looked at our graph and found that out. But I wanted to point this out to you because of something that's going to come later in this lesson and in the next lesson. So if you drop a 0 in there where the x's are, everything should disappear except for that whole number. Does this graph have a minimum or a maximum? Has a minimum, and they tell us what it is right here. You're exactly right. It has a minimum, and that minimum is at 1, -4. Usually when we talk about a minimum, we refer to what's happening with the y value. So our minimum occurs at -4. We don't have a maximum value. If I didn't have a graph, right, and I needed to start somewhere and I need to find the minimum, do y'all remember what you can do? This is kind of a review of the last test. But one thing you could do is type it in your calculator and go to y equals, type it in and do second trace, and then find your minimum that way. We can talk about that more in lab if you would like to see it done. Or I suggested that you do x is equal to -b over 2a. And if you found that, that would give you your 1. And after you find your 1, to find your -4, you plug the 1 into your equation to find the y part. Y'all remember that a little bit, I hope, from test 2? Because that, if you haven't taken test 2, that's how you would find your minimum or maximum if you're not just going straight from the calculator. You do -b over 2a, find that, it should be 1, and then you would plug 1 back into your formula. Domain is asking what could x be? A parabola just gets wider and wider and wider. It just keeps on kind of stretching a little bit wider. So our domain would actually be from -infinity to +infinity. Our range is asking, well, what can y be? So if we start at the bottom and we kind of come up, the first time we have any action happening on our graph is when y is equal to -4. That's why it gets a bracket. And those arrows on our function go up forever. So as we rise, it's just going to it's never going to have a place where we don't have a graph, because we're going to infinity. Okay, let's talk about intervals that increase and decrease. One thing we said about intervals and that increase and decrease is they never have brackets. They always have parentheses. That's one thing. So you could have a bracket on domain and range, but increasing and decreasing don't get brackets. And you're always dealing with you're always considering where X is at when you're dealing with increasing and decreasing. We don't care about Y. So if we're on our graph and we're going from negative infinity, X is kind of negative infinity down here. So we're going from negative infinity. It looks like the first thing I do is start decreasing until I get to the bottom minimum point. So I am decreasing first from negative infinity until when X is equal to 1. It's always in terms of what's happening to X. And then when X is 1, I start increasing again all the way to positive infinity. I really think that the only thing of that wasn't a review of what we've been doing is maybe the y-intercept, but we kind of already knew how to do increasing and decreasing, or we should. Domain and range, minimum, right? The only thing we really haven't talked about is that y-intercept. And when you have a y-intercept, X is equal to 0. Plug it in and you should be able to find it pretty quickly. This function, its highest power of X it has is the X to the third, which is why it's a cubic function. It is a third degree polynomial. Okay. If I want to find my zeros, I could go over here and look at my graph, because the zeros are where it crosses the x-axis, but also they've got this factored already for me. So if I solve x plus 4 equals 0, just making sure you guys know this, because the graph is a little bit easier to tell this than this, but one of my x-intercepts would be -4, 0. That's also one of my zeros. So, and then I could do x plus 1 equals 0. So x equals -1 is another one of my zeros and my x-intercepts. And then I would need to look at x minus 3 equals 0. So 3 would be another one of my x-intercepts. If you need to find your zeros, or sometimes we call them roots or x-intercepts, and it's an x to the third, we can't go to the quad program, right? Because this is not a quadratic. So if on the prior problem, most of you, if you weren't given the graph and you were just given x squared minus 2x minus 3, you probably would have gone to that quad program on your calculator and typed in A is 1, B is -2, C is -3, and it would have spit out -1 and 3, right? Okay, so on the quad program, this is cubic. You can't use the quad program for the cubic ones. So what are you going to do? You could possibly, well, not possibly, you can use the app that says the Poly Root Finder, the Polynomial Root Finder under your applications, and that is at Polyroot 2, and you would type this in. You need to change your squared to a 3. Let me go there real quick. I'm not going to work out the whole problem, but I do want you to at least see what I'm talking about. Maybe it'll load up. I think it must be right there. There it is. Okay. So what I was saying is you could go to your app button, which is right here, kind of diagonal from the alpha, and hit enter, and then go down to Poly Simulator 2 and hit enter. Poly Root Finder, yes, and then go over, since it's an x to the third is our highest power exponent, I would hit enter here. But so you can also do with something that's a fourth root and all of that, and you hit next and you type in your equation. Y'all remember that a little bit? So you absolutely could do that. Okay, but we've got this and they gave them to us. So on the y-intercept for this one, remember that on your y-intercept, what is equal to 0? The x-intercept, y is equal to 0, but on your y-intercept, your x is equal to 0. So if we go write our little equation up here, and instead of the x's, we just drop in x is equal to 0. And you're going to figure out this pretty quickly, that any term that has an x in it, it's just going to go away, because if you multiply by 0, it's nothing, and you're just going to get your constant term. So the y-intercept is going to be the point 0, -12, which we can see on our graph right here. It's a little bit more difficult to see that point, but where does it cross the y-axis? Right there. This thing has both a minimum and a maximum, but they are just relative minimums and maximums, because this graph goes on forever down this way and forever up this way. They gave us what the relative maximum is here. It's -2.7, 12.6. And the relative minimum is the point 1.4, -20.7. If I didn't know how to do that on this, I'm probably going to need to go, you can't do the -b/2a thing here, because this is cubic. So you probably do want to use your calculator to go to second trace and then find the minimum and the maximum, like we did for test 2. Everybody okay with that? Okay. So our domain, it looks like this thing's getting wider and wider. So -infinity to +infinity. It also looks like this arrow is going down forever and this arrow is going up forever. So that would also be from -infinity to +infinity on the range. Okay, so when you look at the top row of graphs, say even degree, the bottom row of graphs say odd degree. What's the difference just in looking at those graphs? What's the main difference? Not the equations, just the graphs that you can describe from looking at those. What's, if you had to say, well, I know this is even because it does what? Or now I know this is odd because it does what? Okay, I heard odd ones go both directions, which when you're describing math, sometimes it's hard to do. I agree. But yeah, look, this one is going, when you look at the end, this one's going down on one end and up on the other end, right? This one's same thing, up on this end, but down on this end. So all of them do that. They're either, if they're up on one side, they're down on the other, and vice versa. But the even degrees, the ends are either both going up or they are both going down. Right? Another thing that when you're looking at, if you're given the equation and you're looking at these, the highest power of exponent here is an x squared, and a 2 is an even number. The highest power exponent here is an x to the 4th. That's an even number. This is an x to the 6th. That's an even number. So if I'm given the equation, I kind of know, okay, it's even or odd by the highest power of exponent. This 3 is odd. 5 is an odd number. It has to be the highest power, not necessarily the one in the front, because this one was in the back, right? 9, those are odd numbers. So I also know if I'm given the equation that those are, if they're even or odd. So one of the objectives that you were supposed to learn today is how to use the leading term test. So this A sub n is talking about our leading term, which is one of the reasons why we talked about the leading term at the beginning of class. If the leading term is bigger than 0, which means is it positive? Then if it's even, both of the ends are going to be facing up. If it's odd, it's going to be kind of increasing. So it's going to start out low, start out small, and get bigger and bigger and bigger. If the leading term is negative or less than 0, both of the things are going to be down. It's going to be making a frowny face. Or if it's odd, it's going to be decreasing from going from left to right. Okay. So I absolutely think that you could work these problems by just typing on your calculator and figuring out which one matches, but that takes some time. And if you can figure out a way to do this without having to do all that, sometimes that helps. And it also helps kind of make connections in the graph anyway. So here's what I know about this already. The leading term here, this is a 4. So this one's going to be even. I know that one. So that means both of the arrows have to be facing the same way. This one right here is a 3. That's odd. That's going to be an odd function. The leading term here is a 5, so it's going to be odd. That means that both of the tails of the graph are going to be facing different ways. This one right here is even. So I know that by just looking at the graph, looking at the equations. So already whenever I'm looking at whether this one is graph A, B, C, or D, since it says even, both of the tails should be pointing the same way. So I know right away, A is pointing 2 different directions. B is pointing 2 different directions. So it's not A or B because it's even. It has to be C or D where the tails are pointing the same direction. So then I want to look at the leading term and I want to really focus on what the coefficient is. And it's a 3. Is 3 positive or negative? It is definitely positive. So if you go look at your things that are positive, that are even, both of the tails should be facing up. So I know it has to be D, because that's the only one that has both of the tails facing up. Okay, this second one is an odd function, which means that the tails are going to be facing opposite directions. So it can't be C or D because those are both facing the same direction. Then I'm going to look at my leading coefficient, and my leading coefficient is negative. You go up here and eyeball what happens to an odd that is negative. It starts at the top, or it starts up high, and then it kind of decreases. So which one is that? Got to be B. Starts big, and then it kind of gets smaller. Okay, this one is also odd, which means that it can't be C or D because those tails face the same way. And the leading coefficient here, since there's no number there, it would just be 1. 1 is positive. So it should be increasing, is what the table says up here when you go look at it. It's going to be increasing, so it has to be A. This one right here is even, but my leading coefficient is negative. So it should be facing down and making a sad face. So C. Everybody okay with that? And like I said, if you get really stuck, you absolutely can graph some of these, but be careful because sometimes the whole graph doesn't fit on the screen. And then you can get confused because if it's something that doesn't show entirely from -10 to +10 and you don't know how to adjust your window, that could be a problem. So that's another reason why you want to kind of know how to do these leading term tests, tell what's happening. Right? So we have already talked a lot about if you have a quadratic polynomial, that if you factor it, you can find your zeros. And so what they're telling us is that they took x squared minus 2x minus 8, they factored it, and then they took and they solved. X plus 2 is equal to 0, and they got -2. And they solved x minus 4 equals 0, and they got +4. And if you go back in the equation and you plug in -2 in for x, you should get 0. If you plug 4 in for x, you should get 0, which is what they did right here. And they've got a graph of it that shows that those 2 points are the x-intercepts. They did the same thing here. They factored it, they solved, they set them all equal to 0, they solved them, And when they plug those in, bless you, that they all equal 0. They graphed them to show that those are actually x-intercepts. So there is something called, I'm going to go back to my objectives real quick so I can make sure I say it right. If I guess there's not a certain term for it, I'm sorry. If you plug in your zeros into your equation, you should get 0 for your answer. Okay, if you don't get 0 for your answer, then that is not an x-intercept. It's not a 0. So on this problem, they're asking us plug 2 in and plug -5 in. So they're saying do P of 2 and do P of -5 and tell me, are those things zeros? So if I plug these in, I'm just writing down my equation that's right above, right here, without any taking my x's out and just putting blanks for x's. They're telling me to plug in and try to see if 2 is a 0 and try to see if -5 is a 0. When you look at your graph, you can kind of tell that 2 probably is not a 0 because it doesn't go through 2. But what we're trying to make sure, we're trying to see, is it equal to 0? If it's not a 0. So if I go to this equation right here, you could type it in your calculator. If you kind of want to cheat on this one, you could go to your y equals in your calculator. You could type that in and you could look at your table and see what the answer is. If x is 2, what is y? If you plug this into y equals and you look at your table, when x is 2, what is y? When x is -5, what is y? That's how you could cheat. Because sometimes when we try to plug things in, we mess up. So this is 8, this is 4, -17 times 2 is -34 plus 15. That's going to be -7. Is -7 equal to 0? No. So 2 is not a 0. It's not an x-intercept. You can tell that from the graph too. We try this one, -5 cubed would be -125. -5 squared is 25. -17 times 5, -5, sorry, is 85. So I do know that if you add 85 and 15 and 25, that's positive 125. So this one actually is 0. So -5 is a 0 because when you plug it in, it gives you 0. It is one of the x-intercepts. You can see it right here, that point, -5, 0. This other point that we looked at, -2, 0, the graph doesn't go through that. You can see that right there. That's why we got -7 and not 0. Okay, does that make sense? If you can plug it in and you get 0 for the answer, then it is a 0. If you can't, it is not. Questions about that? Okay. So we're going to talk about kind of the shapes of graphs and what they do. This is the last thing that we need to talk about here. So, and I know we'll finish a little bit early. We'll start lab a little bit early today. I don't want to go so far ahead today just because y'all are still taking the test. So I'm doing 8.1 and 8.2 this week so that y'all can kind of stay with us. So when you are looking at this, all of this stuff says a bunch of things that kind of don't make sense if you read them out loud to me. But what this is saying is if the exponent here is odd, then your graph is actually going to cross over the x-axis at whatever C is. If your exponent is even, then your graph is tangent to the x-axis at C. I like to say that instead of tangent, it kind of bounces off the graph. Okay, so what are we talking about here? When you look at this graph right here, I can tell that at this place, whatever number that is, that my graph is going to cross the x-axis at that place. Same thing over here. At this point right here, the graph actually crosses over the x-axis. But if you go look down here on this one and you look at this point right here and this point right here, this graph does not cross over the x-axis right here. It comes up and this is called tangent. It comes up, it bounces off it, and then bounces off this again. So these are examples of when it's bouncing off of it and not crossing it. Does that make sense? Okay. So when you're doing this, we're going to talk about several things. You don't worry about any of the terms if they don't have an x in them. So 5 is not really important right now. But the x minus 2 to the third is important. And the x plus 1 is important because they both have an x in them. This 3 up here means a couple of things. So you guys would agree with me that 3 is odd. So one of the things that it means is that if it is odd, that it's going to cross over the graph at whatever the point is right there. So it is going to cross over the graph at whatever the point is right there. So I'm going to write that real quick. Because it's odd, it's going to cross over the x-axis. I know that. Okay, another thing that I know about this 3 is that x minus 2 to the third power means that I'm saying x minus 2 times x minus 2 times x minus 2, right? X minus 2 to the third power means you're saying x minus 2 times x minus 2 times x minus 2. With that comes this word called multiplicity. And this one has a multiplicity of 3 because it happens 3 times. So I know those two things from just looking at the fact that it's odd and the number means that 3 means it's going to happen 3 times. So if I want to find the point that it's going to cross over, I'm still going to do the same thing that we've always done and say, well, set it equal to 0. And so I'm going to have an x-intercept at 2, 0, which it shows right here. At that point, it's going to cross over the x-axis, and there is a multiplicity of 3 because it's listed 3 times. That doesn't mean I'm going to have 3 dots. It just means I've got x minus 3 times x minus 3 times x minus 2 times x minus 2 times x minus 2 3 times. Okay, this doesn't have an exponent up here. So what would be the exponent if there were one? It would have to be a 1, right? So x plus 1 just means that you only have it listed 1 time if there's no exponents there. So this is odd, which means that at whatever point this is, it's going to cross over the x-axis. Okay, another thing I can talk about when I talk about the 1 is that since it's just a 1, it has a multiplicity of 1. Okay, and then when I talk about the inside and I set it equal to 0, I can actually find the point of where it crosses the x-axis at my 0 is at -1, 0, which is graphed right there, shown to you. We are only worried about the things with the x's in them. So this negative right here just represents -1, and there's no x in that term. So I don't really care about that for what I'm doing right now. This and this both have x's in them. So I'm going to jot these down. X minus 1 squared and x plus 2 squared. I'll look at those. This 2 is even. So what does that tell me? That it's not going to cross over the x-axis at that point. It kind of bounces off the x-axis, which we say that is a tangent to the x-axis. When it comes up there and hits it and bounces off, it doesn't cross over. Okay, the other thing the 2 tells me is what the multiplicity is. The multiplicity here is 2, because that means x minus 1 squared means x minus 1 times x minus 1. To find the point that is the x-intercept, I can set this equal to 0. Gonna add 1 to both sides, so x equals 1. So I would have a x-intercept at 1, 0, which we know that. If you look at it, you can tell it went right up to it, it bounced off of it and turned in the opposite direction, just like we thought it would. This 2 is even. That means it's going to bounce off at whatever point we have at our x-axis there. It's tangent to the x-axis. It also tells me that it has a multiplicity of 2. And if I want to find the x-intercept, I would solve this for 0. And so I should have another x-intercept at -2, 0, which I do. And at that point, it bounces and turns around and goes in the opposite direction, just like it's supposed to. While we're here, if you're given the equation and it's not written in this factored form, you can find the roots and turn it around, right? We might need to talk about that a little bit more next class period, but you can find the roots and come up with the equation, the factored form. Let's do this. So I don't care about the -8 because it doesn't have an x. I do care about this term and this term and this term. So I've got x minus 3 squared. I've got x plus 4 cubed, and I've got x to the 4th. And I'm going to kind of come over here and make us a little XY axis. This 2 is even. If it is even, does it cross over or bounce off? It is. It bounces off, so it is tangent. It's what we call that, to the x-axis. I know that. This has a multiplicity. I'm not going to write out the whole word, but it has a multiplicity of 2. If I want to find the intercept, I would say x minus 3 equals 0. I would solve that. And so x equals 3, that point, 3, 0. So 1, 2, 3, 0. Kind of important. I know that's going to be there. Anybody lost? This 3 is odd. That means it's not going to bounce off. It's going to have to cross over the x-axis right there. It also tells me that there is a multiplicity of 3 happening. We'd have x plus 4 times x plus 4 times x plus 4. When I solve this and get the actual point, we're going to get -4 here. And so we would have a point at -4, 0. Know that point is there. Okay. This one could be a little bit tricky, but what you need to do is you need to rewrite this as x minus 0 to the 4th. Do you guys agree that this is the same as this? X to the 4th is just x minus 0 to the 4th, or x plus 0 to the 4th. So this 4 is even, which means that it's going to bounce off right there. So it's tangent to the x-axis. X minus 0 is equal to 0. So really, x is just 0. So I have a point at 0, 0. And at that point, it's just going to bounce off. Okay. Now, without me knowing whether something is increasing or decreasing, okay, just talking about the bouncing and the crossing over, what I can kind of say from this is at 3, it crosses over Now, I'm not saying this is the exact graph because I need to see if it's increasing and decreasing in between. But it could possibly look something like this, right? Because it bounced off at 0 and it bounces off at -4 too. So maybe something like that. And it crossed over at